Good morning, students. In the previous video session, we have gone through two bodies in contact on a horizontal surface, and I gave the Zoom class also. I explained in Zoom class also. So today we can see another important derivation. It is a long answer, question number 3. It is book back question, long answer, question number 3. Motion on connected bodies. Actually, we know that assume that some object we are connecting by using string, and we are applying the force on that object vertically or horizontally or at the inclined plane. Some tension is produced on that. When we are tying something on the string, I told before also, when we are tying the object by string and we are stretching that string, we know that some tension force is acting on that string, and due to this tension force, there is a change, there is a small variation, or we can tell that it will affect the acceleration. So let us see how it is affecting the acceleration, so that we can find the acceleration and this tension in this when two objects are connecting in during vertical motion and in horizontal motion. First case you can consider the vertical motion, and here you can see that two objects of this diagram, just to go through that. So here you can see that two blocks, M1 and M2, and here M1 is greater than this M2. It is connected by a, you can tell that, light and inextensible string, very thin string, and it is passing over a pulley. Now what will happen to this? You can see that this T means what? The tension in the string, and A means, you know, that acceleration. So what will happen when this system is released? When we are releasing this system, we know that this will move down, isn't it? Because this mass 1 is more than this mass 2, so that it will move in downward vertical direction. So M1 will move downward with the acceleration A in the same direction. So the gravitational force M1G will act on the mass M1, and this mass is used to lift water, the mass M2. If you are drawing the free body diagram, you know that for mass M2 what will come? Upward tension, downward this M2G. For mass M1 what will come? Upward tension and mass M1G. You can see that free body diagram as well. This direction is very important. Now we are applying the Newton's second law for mass M2. The first thing is applying Newton's second law for mass M2. Newton's law. So we know that F is equal to ma, that F is equal to ma we are applying for mass M2. When we are applying this Newton's second law on this mass M2, how it will come, you see the equation. We know the equation F is equal to ma. So the total force is upward acting is tension force and downward acting is gravitational force. So tension is acting upward direction, and upward means this is in the y axis. Y axis means this is positive y axis, this is negative y axis. So for positive y axis you can use what? J unit vector, and this minus j y axis. So you know that this is a diagram. Here tension, here M2G. This is mass M2, this is tension. So this is moving in the direction of positive x-axis, y-axis. So you can use J unit vector, and here this M2G in the direction of minus J unit vector. Now you can apply the Newton's second law. So F equal to ma. What are the total force here? Tension. So tension is acting in the direction of J unit vector plus M2G is acting in the direction of minus J unit vector is equal to mass 2. Acceleration where? So this mass 2, you know that from this mass 2 will move upward direction. So when the mass 2 is moving upward direction, acceleration is in upward direction. Upward means it is in the direction of positive y axis. So acceleration in plus J unit vector. So acceleration in plus J unit vector. So you can write this T J unit vector plus M2G J unit vector. You can take this minus here so that here minus will come. So equal to M2 A J unit vector. Now comparing this component so that this vector values will change J and all, so that you can write T minus M2G is equal to M2A. From this you can write T is equal to this minus M2G, we can take it that side. So M2A or M2G plus M2A. This is equation 1. So applying Newton's law on mass M2. Now you can apply the Newton's second law on mass M1. So now Newton's law. On mass M1. So let us see how it is. So you see here, this is mass M1, upward tension is there, downward M1G is there, and acceleration, this M1 acceleration is also downward direction. So this tension is in the y-axis, positive y-axis. So you can use plus J unit vector and M1G downward, so minus J unit vector, acceleration also downward, so again minus J unit vector. So that this is the thing, mass M1, downward M1G, upward tension, acceleration also downward. Okay, now this one not in the diagram, I just for indicating to know the direction. So this is in the positive y-axis, so plus J unit vector, tension M1G downward, so minus J unit vector, acceleration also minus J unit vector, same direction. Now you can write the equation, F is equal to ma. What is this total force? Upward T, downward M1G. So T J unit vector plus M1G minus J unit vector equal to acceleration. So M1 Ma. Ma means M means here 1. So M1 A minus J unit vector. Now you see how this equation will change. Tj unit vector, this minus will come here, minus M1G J unit vector is equal to minus will come here, so M1 minus M1A J unit vector. Now you can compare the component, so what will come? T minus M1G is equal to minus M1A. Here we need to find out this, we can rearrange this equation so that what will come means minus M1G plus T is equal to minus M1A. So if we are multiplying by t, then we can change this minus. For that we are doing, so m1g plus t is equal to m1a. This is equation 2. Now what you have to do means substitute 2 1 in 2. Substitute 1 in 2. So equation 1 is what? M2G plus M2A. T value is M2G plus M2A. The T value you have to substitute here. M2G plus M2A. Here you have to substitute in this equation, so that you see how it will come. M1G plus, instead of T you have to substitute this M2G plus M2A equal to M1A. Okay, you can go through this. Now here M1G, M2G. This side M1A. So take this M2A this side. Take this M2A another side. When we are substituting here, what will happen means, so here there is a small problem. When we are multiplying by minus in this step, here will come minus. So M1G minus T. So here when we are substituting equation 1 in 2, 1 and 2 means M1G minus this thing will come. So I'll write this M1G minus, in bracket you write instead of T, M2G plus M2A equal to M1A. Now multiply this minus inside, so M1G minus M2G minus M2A equal to M1A. Now this G you keep one side, A you keep another side. So M1G minus M2G equal to, now I am taking this one this side, M1A plus M2A. Now G common, take it outside. Here A common, A take it outside. So M1 minus M2 into G equal to, here M1 plus M2 into A. So rearrange, bring this A this side. We are finding acceleration, so that M1 plus M2A equal to M1 minus M2 into G. Now A is equal to M1 minus M2 divided by M1 plus M2 into G. This is equation 3. Now if we are substituting, it's assumed that this mass M1 and M2 equal. Mass M1 and M2 equal means what will be the acceleration? Acceleration we will get 0, because M1 minus M2 0 will get 0 divided by everything 0 you will get. Also the mass M1 and M2 is same means what? Acceleration. There won't be any acceleration. Now what you have to do means you have to substitute. We need to find out the tension. That is what, keep it in mind. So substitute equation 3 in equation 1. This is equation 3. So A value you have to substitute in here. So T is equal to M2G plus M2 into A value substitute of. So T is equal to M2G plus M2 into A value. A value is M1 minus M2 by M1 plus M2 into G. Now next step, T is equal to M2G plus this m2 you multiply inside. So what will come? m1 m2 minus m2 m2 by m1 plus m2, separating this, here g is there, so by m1 plus m2. Now take the LCM, that means you multiply this with here, so that what will come? T is equal to m2g into m1 plus m2 multiplied plus m1 m2 minus m2 m2 into g. Now divided by m1 plus m2. Multiply this m2 inside. Here you multiplied this g inside. So t is equal to m2 m1. So m1 m2 you can write into g plus m2 m2 into g plus m1 m2 into g, m1 m2 into g minus m2 m2 into g, m2 m2 into g divided by m1 plus m2. Now you see here this m2 m2g plus m2 m2g minus m2 m2g cancel. So remaining is t is equal to m1 m2g plus m1 m2g divided by m1 plus m2. Now you see we go to this equation, add this equation here, 1 plus 1, like that only, no, 1 m1 m2g plus 1 m1 m2g, so that 1 plus 1 is t is equal to 2 m1 m2g divided by m1 plus m2. This you can write a little stylish, so that 2 m1 m2 by m1 plus m2 into g. This is equation 4. Now you see here you go to this tension equation. Now for mass m1 acceleration vector, we are writing the acceleration. We know this is our acceleration equation. This equation we are writing in vector form. For mass m1 acceleration is, this is a mass m1, acceleration is in downward direction. Downward direction means it is minus j vector, and mass 2 acceleration is upward direction, it is in plus j vector. So that along with this acceleration we are adding minus j unit vector. So here minus will come for mass m1. So minus j vector added, here minus k. Next one for mass m2, what are? Mass m2, it is moving upward direction, that is in the direction of positive y axis, so plus j unit vector. Okay. Now you can take second case, it is horizontal motion. Now you see in this table mass 2 is arranged and mass 1 is kept over a pulley. Now you see mass 2 is this, tension is like this, and this acceleration also in this direction. You can see here mass m1, tension is upward, gravitational force is downward. Now if you are drawing a free body diagram for mass m2, mass m2 is at rest, so that there must be gravitational force downward and upward normal force. This is just for identifying I gave. So that if you are writing case 2 horizontal motion, we have to draw the free body diagram for this. This diagram I am drawing. So listen how I am drawing. So for mass M1, first for mass M1. So mass M1 is this one. So mass M1. So putting mass M1, downward is M1G, upward is tension. So for mass M2, downward is gravitational force M2G, upward is normal force, this direction tension. So this is what the free body diagram. Now what you are doing means, what are the forces acting on mass 2? So that is what before I told. Forces acting on mass 2 are downward gravitational force, upward force normal force, and the horizontal tension. You see, this is mass M2, downward gravitational force, upward normal force, then tension force, and in mass M1, upward tension and downward gravitational force. That is what here given. Then free body diagram. Now applying Newton's second law on mass M1. So that what will happen? So this is mass M1. So let us see what will happen. Applying Newton's second law on mass M1. So first mass M1 I am applying Newton's second law. So that T upward direction. So T J unit vector. This is y direction only. So this is what? X, Y. Now downward is what? See, plus M1 G, and this is in downward direction. So minus J unit vector equal to MA. MA means what? This is a formula. F is equal to MA. F means this is a total force, upward, downward. Acceleration is which direction for mass M1? Let us see. This is mass M1. So acceleration downward direction. So downward only acceleration. So M1A, downward means minus y axis. So minus J unit vector. So TJ unit vector, this minus I am taking here, M1G, J unit vector equal to M1A, minus I am taking here J unit vector. Comparing the component, so T minus M1G equal to minus M1A. So this is equation 5. Now applying same Newton's second law on mass M2. I am applying Newton's second law, F equal to MA. M2 is this one. So X direction tension is there, X direction. So X direction means tension. X direction we are using component vector I. So tension in the positive X axis. So I using I unit vector. So T I unit vector equal to acceleration also this direction only. So M2A I unit vector. So comparing the component, T is equal to M2A I will get. So this is equation 6. Now this is X direction. Now Y direction is there. So applying Newton's law on Y direction. Okay, Y direction means upward normal force. So N J vector, J unit vector plus M2G. This is minus G unit vector. So you can write n j unit vector minus m2 g. Okay, plus you can get, because F is equal to ma formula. Forces acting upward is normal force, downward is gravitational force, and downward direction is minus j unit vector equal to m2 into a acceleration. Actually this direction no acceleration, so you can put zero acceleration. So nj unit vector, this minus will come here, so minus m2g j unit vector equal to 0. So comparing the component, so n minus m2g equal to 0, n is equal to m2g. This is equation 7. Now you have to do substitute 6 in 5. So 6 in 5 means this t equal to m2a you have to put here in this equation. T equal to m2a you have to put here. So m2a minus m1g is equal to minus m1a will come. So m2a minus m1g is equal to minus m1a will come. Here a take together, so m2a plus m1a, this minus m1g take it that side, so plus m1g. So you can take this a outside. First you rearrange m1a plus m2a equal to m1g. So m1 plus m2 a taking outside equal to m1g. So a is equal to m1g by m1 plus m2. Acceleration got this is equation 8. So now what you have to do means you have to substitute 8 in equation 6. So this acceleration value you have to substitute here. So t is equal to m2a. So t is equal to m2, instead of a you have to put m1 g by m1 plus m2. Multiply this. So t is equal to m1 m2 by m1 plus m2 you will get g. So while comparing this tension, horizontal motion tension and the vertical motion tension, here we got 2 m1 m2 by m1 plus m2 into g. Here we got m1 m2 by m1 plus m2 into g. So it is clear that the tension in the string for horizontal motion, this is for horizontal motion, is what? Half. There we got 2 m1 m2, here 1 m1 m2. So this is half times less than what? The tension for vertical motion. So my dear students, all of you go through this. You can take a screenshot if you need. I will hold the mobile like this, so it will be easy for you to take the screenshot. And next page. Next page. All of you take screenshot of this, so it will be easy for you. Take screenshot and write in your notebook. Thank you all. Bye bye.